to my party, we're just getting started. A life is a dream or a nightmare scarring. Hand me a drink, cause I think I'm going all in. Get me a shrink who can catch me when I'm falling. Cover up my scars, flip the handlebars, crashing in my car, wake up in a bar.
Alrighty guys, welcome back to the channel. It is a nice crisp October morning here in Austin, Texas. Sorry, I got some road noise behind me. I'm walking back to my apartment after a little morning walk. It was hot in the apartment, so I wanted to walk around for a little bit, enjoy the cool breeze. But today, I'm going to be taking you through first, let's take a second. If you haven't seen our last video, go ahead and go watch it. After an off week, Andrew went and got some work done on our project 67 Mustang, so pretty cool. He's making progress on the roof. You know, there was some issues. He talked about it a little bit and even left out some more issues that he had.
Meanwhile,
all right, roof is finally painted. It took way too long, but it happened. We had a couple problems I'll show.
But today I'm going to take you through. So for my classes, I got to design a random CNC part. And I have to design it and write the cam coding for it. So today I'm not going to take too much through the design. I'll show you once I get inside here, but I just started off with a little horrible sketch on my iPad, and I was just brainstorming, thought, you know what? I was going to try to make something useful, like a cover that goes on the top of a Fox body intake, like the stock intakes or the Explorer intakes. If y'all know, it's the little like trapezoidal piece that goes over top, says like 50 HO or 50 EFI. I was gonna make that, but I couldn't find any dimensions for it. I have a plate at my house that I could have taken dimensions off of, but again, I'm not there. So yeah, so I just started thinking. I was like, you know what? Let's make something to do with that fastback of mine. And so I was like, what can I do here? What can I do here? And then it hit me. I was like, I'll make a little key holder. So it's basically arts and crafts time today. But yeah, I'm gonna walk back to my and then later in the video, you might see some clips from the F1 opening qualifying day here at COTA. I'm going with a friend of mine, and I'll make sure to get some clips for y'all. I might not do a full walk around video tour of it because I want to be enjoying it. But I'll get some clips for y'all, and we'll include that in the end of the video. We kind of fell off on our normal schedule, but that's just how life just gets in the way. I've been a bit busy as heck over here, just trying to graduate, really. But things are calming down just a little bit, so hopefully I'll get this video out for y'all, get it to Andrew so he can edit it, and then we might start doing the podcast things. We're still trying to figure that one out. Might film the first one this weekend, but yeah, let's get back inside. And I already did a little bit of designing last night. I got a video of that for y'all. We'll include it in here just as a time lapse. But let me get inside. I'll show you the setup and just kind of what we're doing. Alrighty, guys. So here's the setup. We got I just got my TV plugged into it to give me a little bit of feedback while I'm recording myself on the computer here. But yeah. So I got my computer here. Like I said, Dell XPS 15 works great for doing this kind of stuff. I'd like to point out this mouse that I use because everyone makes fun of this mouse I use being a trackball mouse, but let me tell you, I don't know. Everybody tries to use it, doesn't know how to use it, but I'm telling you, you're getting into doing CAD work, trackball mouse or a spaceball, those are expensive. But a trackball or a spaceball, that's the way to go. You can CAD with it down here on your leg, move around just fine. Anyways, but yeah, I get crap for that all the time, but I love it. But so this is what I started off with. I'm sorry about the camera here. I don't know how to cast off the iPad here, but yeah, so I just started off with a sketch. I was just making sketches of what I thought it should look like, and this is what I came up with. I was like, that looks pretty cool. 3D print this bottom part to have the key hooks, CNC everything else, and one of y'all might be, if y'all are going through school and have to take notes on an iPad, I highly recommend paying for GoodNotes. Like, it might sound odd to have to pay for a notes app, but GoodNotes, very good. You can record the teacher talking, so you can take notes later, or if you have to record anything, you can do that. It doesn't record video, just audio, but it's an awesome notes app. Works great with the Apple Pencil here. Just saying, love it. Also, one of these fine point writing pencils. Just got one of these from my girlfriend, and they are very nice. I do like them because I recently dropped my my Apple Pencil very vertical onto the ground, and it dented the end, so I had to get a new end.
Dropped it perfectly vertical, Morty. Perfectly fucking vertical.
Anyways, so start off with this, and then we'll just throw this out of the way. Just kidding. It's expensive. Don't want to do that. I cannot afford to have to get another one of those. But going on here, and this is what we ended up with. So as you can see, now we are doing this on a full 4-axis CNC, or I guess the one we're using is only a 3-axis. But still, this could be done on a 2D, 2D router like the one I have at home, which you'll probably see in later videos. But yeah, so here it is, just made to look like a 66 fastback. Notice here I got this would be where they had like the glass window instead of the louvers. Due to the tools we have available, I can only use a 1/8 inch end mill, smallest one I can use, and it just wouldn't make sense to try to put louvers in there. It'd be too small. But anyways, we're gonna end up machining this out of brass. I got that okayed yesterday. They got the parts ordered, or they got the material ordered. So yeah, so that should be pretty cool. I'll put a little name placard right here, just 3D printed, and down here these are gonna be threaded holes to bolt up either a wooden or a 3D printed key holder area. But this main part back here, this main body, all brass, freshly machined, holes for mounting. But yeah, so and this was just done using just basically sketches. I started off with let's see here. Let's see if I can show this. I started off with a picture in here. We're just gonna go ahead and hide this. So I started off with a picture, which is courtesy of, let's see if I still got it pulled up, courtesy of, let's exit out of here. I got it off of Reddit. This is from, well, probably shouldn't say that, but okay, yeah, here it is. Megalithic Man, yeah, Megalithic Man, posted April 7th. I don't really know how Reddit works. Anyways, but yeah, credit where credit's due. Beautiful car, man, beautiful car. If you see this, probably won't, but if you do, beautiful car. It's just a nice side profile pic, so I took that, started putting the sketches through it, and then just started extruding it and just kind of layered it to give it depth. But yeah, let's go ahead and we'll insert the time-lapse footage of me recording that. Alrighty guys, here we are back on SolidWorks. Also, just so you know, if you're a student, you get a student discount on SolidWorks. If you go to a lot of universities, they'll give you a free code, but the student edition is only like, I think, $100 a year. Sounds kind of expensive, but these softwares are very expensive if you have to buy it otherwise. And don't quote me on that price. It could be cheaper, could be more, who knows. But yeah, so we'll get off of SolidWorks here, and we'll move into Fusion 360, which I'd also like to mention is free for the student edition. You don't even have to, okay, you don't have to be a part of a university. You can say you're a part of it. Hey, I am not saying you should do this. I am part of a school, and also high schools do it too. Sign up with your high school. If you're young and you're interested in doing this kind of stuff, Fusion 360 is perfect. You don't really need anything else. Fusion 360 can generate G-code for 3D printing. You can model in it, and you can generate CAM for CNC machines. So yeah, and it's 100% free for the student edition. And so all that means is you can't make money off of it, which is good because I don't plan to sell this. So, but yeah, so let's go through it here. You might notice I made it gold just to kind of match the brass it's going to end up being. I was stuck in between doing it in aluminum or doing it in brass, and ended up doing brass because my professor wanted to see it and wanted to kind of showcase it in brass. But yeah, also I'd like to point out a little bit of a design bit I left in here. You notice how it's more flat down here at the tire than it is at the front. That's to kind of give it the impression that it's taking off. It's unloading the front tire just a little bit. But there'll be a black 3D printed or a wooden road surface that it'll ride on, so it'll make sense why the tires are flattened down here. But let's go ahead and get into it. This facing operation wasn't strictly needed, but for the class I have to show that I know how to do a facing operation. And so we got this right here. Just go ahead and simulate it while I talk about it. And but so it's going through here, and I could have faced with a much bigger, ooh, this is really slowing down my thing. We might not be doing this very much longer. Hopefully that didn't look so bad. I think it might have slowed me down. But yeah, so you could have done that with a facing mill or a much larger end mill. This is just set up with a 1/4 inch end mill. And that is to maintain a certain amount of, when you get a CNC part, there's like striping on the surface. Let's see if I can show the tool paths. There'll be striping on the surface. That's to maintain that in this part because the rest of the part will have it. And I didn't want that to just be one pristine, shiny bit right here. Here, let's go ahead and close down SolidWorks. Just go ahead and click save. And that should free up my computer here. I'm in need of a new laptop. And we'll just close all this. We'll leave that open for right now. Close this. Sorry. But yeah, that was just to leave some striping on there. But if you noticed, it took off. So the overall stock dimensions here, you can, let's start with that. Go to setup. First, exit simulation. So first, when you're uploading a file from SolidWorks onto Fusion, if you design it in Fusion, you don't have to do this step, so just skip it. But if you're uploading it from like SolidWorks or AutoCAD or something like that, you can just click upload right here. AutoCAD might be different because they're owned by the same people, so who knows. But for me, upload, that's all you got to click. You got to click upload, and you can see I tested it with another one, and this is the one we're on right now. Or sorry, pointing at the screen, you can see that. You just upload it, put it on there, double click it, and then it opens. And then units right here, you would set it to, if you're working in millimeters, which I do not think very well in millimeters, so I kept it in inches. Just what I'm used to. But you can change that to millimeters or centimeters if you so choose, or meters. Hey, you got something really big you're doing. I think you can change it to feet. Not too sure about that one actually. Yeah, so then you go into setup. You'd click setup right here, and it would pop up right down. Or first, when it opens up, you're going to be opening up in design, which is where you can add to the model. You can loft it, extrude, and do stuff like that. We might have a video later in the series when I have more time. I'll take you through modeling a simple part. But this kind of putting the cart before the horse, and we're going to do this first. We're going to do a little out of order because this is a little more interesting, I think. So we got the setup here. So we'll click setup, and then it'll pop up down here, and you can go in, and we're going to be doing milling. You can change it to additive, so that's 3D printing. Cutting is like laser cutting. Turning, if you have a CNC lathe, which isn't very common. We do have one, and it was an option, but I just couldn't think of a part that needed to be CNC lathed. You can choose your origin. So right now, my origin is set up right here. This is where you would indicate off the part, and that's how the CNC knows where to start from, essentially. We got our stock. It can do a relative sized box where it would add a layer on each of the surface, on each of the, like create a box around your part and give you the same amount of distance on each edge. But I went ahead and did a fixed size box, and it's gonna be a 4 inch by 8 1/4 by 5/8 of an inch thick. The whole part is less than half an inch, but you gotta have enough to actually hold on to it into the vise. But you set that up. I set it up 1/8 of an inch off the bottom surface, so that pushes that bottom surface that's used for clamping up out of the way, so you can still cut your whole part. You do that. Post processes. This is where you can change your number. We'll just change this to just be fun. You can just do like that. You can put a comment on it. ME350 part. That's the class I'm in, so there you go. I'll just click OK. So first, like I said, start off with a facing pass. And to do that, you just go in, and when you do a facing pass, if you click, it'll be right up here. You click face, it will automatically see the highest flat surface on your part. So you don't have to worry, it'll just go ahead and take it down to that height. But we'll click, and you go through here, you can select your tools. There's a whole bunch of tool libraries you can use that you can download. But yeah, there's pre-made tools. You can program in your own tools by clicking the little plus up here. If you have tools that you are using, you can program them in. But you go through here, passes. You can click stock to leave, so you can do a finishing pass later if you wanted to. And I might look at doing that. No, there's not enough stock to leave. I was going to say you can end up doing that, and then you can have it adaptive clear the top part here so it all looks the same. But it might look kind of cool with this being a little different. And you notice a lot of what I chose to do for the milling operations was to get certain looks. And that's something you can look at when you're doing CNC milling, because everything's going to leave essentially that CNC stripe. So if you can play around with your tool paths to get it to look like you want it to look, it's just another layer of your design that you can go into, which I thought was pretty fun when I was programming this yesterday off camera. Probably should have took a video of that, but I wanted to shorten it down because I like to talk about this stuff. So
Today, Junior?
I'm just, no need to show you me doing it. So we'll just go ahead and move my, let's see, cancel, click cancel down here. Let me move my face out of the way so you can maybe see a little better. I don't think we're going to be doing anything up in this corner. So yep. Then next we do into this 2D pocket, or no, we're doing this adaptive. And the adaptive is this. Adaptive is super easy to use. All you do is click it, and it'll open up this dialog box. You choose your tool. Again, I'm keeping the 1/4 inch tool. Just do a lot of the roughing. Your geometry, it automatically selects all of your bodies. You can tell it to ignore stock less than this. This is like if you have a real thin areas and you don't want it to mill that yet because you're waiting to finish machine it. You can do it like that. The heights, don't really gotta mess with the heights tab too much. You can look at it. It gives retract and clearance heights. Passes, this is where you could set up the optimal load, and that's something that's special about adaptive clearing. It will automatically keep the optimal load throughout the whole cutting process. So it's essentially the most efficient way to remove material, and it is a really cool feature that Fusion and a lot of other CAM packages give you. But you can change all these settings. These are all machine specific, so you just need to go through that on your own and look up what you should do on your machine and stuff like that. This stock to leave, you can it does what it says. It leaves stock so you can do a finish pass later, which I ended up leaving 0.2 inches in the radial direction, that's the outer surface, and in the axial direction, which is the depth, like into the screen in this case. But go ahead, you can leave more if you want to. I just left that. That's the default. Just went ahead and left that in there. So that would end the adaptive there, and it's going to clear that, and not sure what it's thinking about right now because I didn't really tell it to do anything else. At least I hope I didn't. But it'll generate the toolpath, and this will be what it's doing. Yes, it is this slow in person because my computer is getting kind of hot. But and then next, I did the 2D pocket, and that was to get these surfaces right here to just look a little different. I could have adaptive cleared the whole thing and had it where it had essentially swirl marks everywhere, but I wanted these to be nice sweeping lines, especially up here. It'd be a nice sweeping line following the curve. So then, to do that, you'd go up here, click 2D pocket, and then go to geometries, and see I just selected these two areas right here. Go to passes, make sure you turn off stock to leave because I want this to be the finishing pass. And you go to heights. Again, what I mentioned earlier, heights don't really change. Multi-axis, you are doing a 5-axis machining thing. You have to do it like that, but this is 3-axis. So anyways, you do it like that, click OK. It'll generate the toolpaths, and let's see here. So it'll go meow, 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 and just go through, make nice sweeping lines, and then up here it actually follows the curve, which I wanted to do. This was what I was talking about, how you can change your machining method to kind of make it look like you want to do. You got to, and that's just something to think about, like I said. But it'll make nice sweeping curves, take off all the extra material on the edge. And then next, I did a 2D contour, which a 2D contour is just following a curve all the way around. And that was to, and again, all these settings are going to be the same. You select the tool. I'm still using the 1/4 inch. I haven't switched over yet. But you go and you select this closed chain, and that'll be the outside surface. So it'll mill these radiuses here, and the stock is a little longer, so it'll mill down how you need it to be. Do heights again, same thing. Same thing here. You can do stock to leave. I turned off stock to leave because I wanted it to mill to final shape. And linking, don't really need to go into that yet. I might go into that in a later video, but right now, not important. Click OK. And we go to the second 2D adaptive I did. And this was to take the rest of the stock off. I left a 0.002 or 0.02 stock to leave everywhere. This is going in with an 1/8 inch end mill, which allows it to mill small features like this and into the corners. And that's something important to mention on the design aspect. Whenever you're doing something like this, you want to design in these inner radiuses to be just a hair bit bigger than the smallest end mill you'll be using, so it doesn't just go like right into the corner. It goes, it kind of just goes around. Just something to look at. Makes the cutting processes go a little easier. So in this case, I did 1/8 inch end mill, so that radius would be 0.625. The inner radiuses on all these inner fillets are all 0.08, so just a little bit bigger. But you go through here, and geometry, like I said, it will just look at your whole thing. And important to do if you're trying to take off that final layer, you got to click this ignore stock. You got to make that 0 so it just goes everywhere that there's extra stock. You can change that a little bit to finalize it. I might play with that a little bit. But you go to heights, same thing, passes, turn off, stock to leave, click OK. It'll generate that, and it will, let's see here. Man, it really does not like doing this. But it'll go through here. You see all these, it'll make all these little lines, go through here, get the back quarter window, get the main window, get the tires, do all that. And then lastly, it'll do the body. And it just, whenever it does an adaptive clearing pass, and there's so many other forms of milling on here that I'm not going to get to in this video, but what adaptive clearing does on the 3D adaptive is it breaks it all into different layers and then basically works its way up. So from the deepest one to the highest one, and it just works its way up. And that's essentially what this this adaptive does. This is like 3D adaptive clearing. This 2D adaptive, it only does the layer that you're looking at right now. Like, you choose the layer, and it will adaptively clear that. And like I said, contour. But then this drill feature here, this one's pretty simple. You go in here, you select this drill up here. You go in, you select your tool. This is a number 30 drill bit for a 4mm tap. It's just the screws I have on hand and the tap I have on hand. And yeah, 4mm tap. See here, you go to geometry, you choose all 4 of your holes. It'll link them all together. This one's really simple. You go here, you can change it to just drilling, wrap it in. It'll just go, whereas the chip breaking kind of goes, just to kind of break the chips. Not needed, but I just wanted to show that here, so I left it on here. Click OK there. Then this drill 2, this is simply to add in this little chamfer right here. Okay, and let's see if I can. But yeah, this is just to add in this little chamfer, and to do that, you can copy the drilling procedure here, and you choose. In this case, I think I did a 3/8 90-degree center or spot drill, which is just like a V-shaped drill. It'll just come down, and you select. You go into geometry here, and you select that chamfered edge, and it will only go down as far as it needs to hit that chamfered surface. And then you click OK, and then there you go. It is set. The setup's fully done. If you look here, the milled material coming off is pretty much right on where the model is, and that's how you know it's good. You don't see any red. You can run through you click setup here, and you can run through the simulate with machine. We'll slow it down just a little bit, but it'll go through here. This does the facing. This will start doing the adaptive. I kind of skipped through it, just kind of fully going through the adaptive clearing. This is the first adaptive clearing with the 1/4-inch end mill. It'll go through here, get all that done, and we'll skip ahead. This is the 2D pocket that I did to get the nice straight lines on the background of the image. Go ahead and skip forward here. This is the 2D contour that is simply going around the edge. Sorry if this is really buffery. I'm trying to keep that from happening. Then this is the last contour where it just uses the 1/8-inch end mill and just kind of goes over the whole thing and takes the remainder of the material off. So, I mean, there's really not too much to all this. We'll go to the drilling. Just go jump. It'll go down to the other side, and then you do the chamfers. It'll hit all the chamfers. If you notice, that first drill started here, went boom, boom. Pause this. It went boom, 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 boom. And then the rapid the chamfer one went boom, boom. It starts where the other one picks up. You don't have to do it like that. That's just a tool pathing thing, and I actually might change that because it doesn't really make sense to do that. But yeah, go to the next point. It's done, so you can turn off tool paths, and this is essentially showing you what it would look like after it's done being milled. You can see you have this little bit of extra left over, and that's what I was talking about. That is that's the remainder of the material that's being clamped in the vise, essentially. So you have all that. Make sure that you program it into where this does not hit, or you set it up in a way that it can do this without hitting the vise. That would be very bad. Let's see. And we can change that stock material. You can change that. But click. That's good. And then that's pretty much it on just a quick overview. I'm trying to keep these videos not 2 hours long because you could do a deep dive into this stuff. And but yeah, so that's pretty much it on how to, how I quickly went through and program the cam for this. It's very easy to get into it if you really wanted to. You just play around, just make a part, and then just play around on how you would machine it. it tells you when there is issues. That's what's nice about Fusion. It tells you when there's, it's a whole lot different. I was just talking with my dad about how they used to do it back in the day when you'd have to write out the G code, which is not fun. And in fact, let's see if I can get it to generate a G code program for us. Whatever. Post. Let me show you what you'd have to do if you wanted to write the G code. And it is just a bear. So look at all this. There is.
Would you look at this?
Yeah, well.
Would you look at that?
Yeah, there's a few more blemishes on the car.
Oh my gosh, just look at it.
Oh, don't want to do that. Look at how much code there is that it is writing just to do this part. Back in the day, you used to have to write this by hand. That is 17,000 lines of G code. You don't want to do that by hand. That's what's nice about, living in the day we are now. You got a real easy CAM package that'll do pretty much all this for you. Down here, forgot to mention, it says this will take 43 minutes to create. And this is something I don't think you could do on a manual mill. So, we've come a long way in what we can do. But yeah, just go ahead and download Fusion. Like I said, it's free if you play around with where you go to school. Or if you go to school, you can do it legit. But you just put in an email, say you're going to school. It'll work. I'm not promoting that, but go ahead and give it your best shot if you want to. But yeah, so I'll end up in another video. I'll do some more. I'll show you the designing in CAD a little more in depth when I'm doing the bottom 3D printer part, and then I'll show you like the Cura slicer settings for a 3D printer. That'll be our next video, but we're gonna wrap it up here. I'm gonna try to convince them to let me record while this is getting machined. Who knows how that'll go. So in a later video, it might get tacked on to the end just to show progress, and I'll come back and show y'all some more stuff on this once it's done. And I got a whole bunch of stuff for a senior design project. You might see in another video. I'll just do an overview of that, which I think is pretty cool. Once I start making parts for it, got all kinds of metal laying around me for this project. But yeah, so let me get wrapped up here, and then I got to get ready and head to Coda. And like I said, you should be seeing some clips of that and maybe a whole video, but we'll see how it goes. Clips, some shorts. We'll tack some clips on at the end of this video, but anyways, this might be the last time I talk in this video, so thanks for watching, and please like and subscribe. Like I said, go watch our last video. Give Andrew some love in the comments of working on that car. Hope you liked this video. It was kind of cool, and I hope this turns out good, and I hope you end up liking it. But this was just a brief overview of some CAD design, showing how you can use a picture and doing some sketches. Didn't really go that in depth, but then brief overview of how I program the CAM program for this. So, but yeah, thank you for watching. If I could just figure out how to pause it, that'd be nice.